Hello there, how are you doing? My name is Esther Ademijo. I have a quick question for you. As a student nurse or as a nurse, have you had problems solving your medication calculations? And do you have a lot of formulas with you, but sometimes those formulas they don't work for all types of medication calculations that you have to do? If you are in that boat, then you are at the right place, because today we are going to be looking at a one-stop method for all your medication calculation problems, and that is called dimensional analysis. All right, so let's get started into that together. So let's look at the objectives that we must achieve at the end of today's tutorial. One of that is defining dimensional analysis. We need to understand it, right? Like, what is this dimensional analysis all about? And secondly, we're going to look at some metric system and conversions, some important conversions you gotta have at the back of your mind. And finally, we are going to spend some time performing some dimensional analysis on various types of problems, three types of problems: one type conversions, weight-based calculations, and drop per minute styles of calculations. So grab a paper, grab a pen, and grab your calculator or your phone and join me. Okay? So what is dimensional analysis? If you have ever been in a chemistry class or course, you have probably seen this before. It's also known as the unit analysis. It's a situation whereby we're using systemic and organized approach to solve math problems. We're using metric system, we're using conversion system, and it just makes it so much easier because we can easily set up these questions and get our go. So with dimensional analysis, we eliminate all memorizations of so many formulas. You don't have to memorize so many formulas. You know this, and that's it. It's your one method to all medication problems, calculation problems, and you are gonna see that as we go. Right here we have important conversions that you need to know. Unfortunately, we cannot do dimensional analysis effectively without knowing conversions. So you need to know that 1,000 microgram is equals to 1 milligram. You also need to know that 2.2 pounds is equals to 1 kilogram, 1 pound is equals to 16 ounces, 2 tablespoons is equals to 1 ounce, and so more. In fact, what I have on the screen right now is not all the conversions you need to know. There's so much more. Right here on the screen is a pictorial representation of how you can easily do your conversions. So you have kilogram, gram, milligram, and microgram. So kilogram is the biggest, and we go down the line. I like to think of kilogram as the dad, gram as the mom, milligram as the baby sister, microgram as the baby brother. All right, so if you were going from kilogram to gram, for example, if you had to convert 10 kilogram to gram, you would multiply by 1,000, and that would give you 10,000, going from big to small. But if you were going on the reverse way, if you were going from gram to kilogram or from milligram to gram, you would divide by 1,000. So that's what this is basically showing you. It's a quick way to remember, oh, how do I convert from kilogram to gram? Oh, I multiply. How do I go from small to big? I divide. So we have 6 rules. Yes, 6 rules of dimensional analysis. The first one is you need to start with what you are looking for. Some questions will ask you, how many milliliters would the nurse give? You need to keep that in mind. What are they asking me for? Milliliters. Keep that in mind. Second, you need to transfer units across. You're going to have a lot of units. You're going to have milliliter, micrograms. You're going to have to transfer all of that. And this will make more sense as we do some examples. 3, you need to insert what you know. If you don't know it, you have to convert. That's why we talked about conversion. 4, repeat step 2 and 3. 5, multiply across and divide. And finally, round your answers and submit. You're good. All right, so let's dive right into looking at some examples.
So the first example that we are going to do is a one-step conversion. The rules I have on the right lower corner for us to refer to. So this question says that a client is prescribed 200 milligram of liquid valproic acid. Valproic acid is available as 250 milligram per 5 milliliters. How many milliliters would the nurse administer? Record your answer as a whole number. So going back to our rule, the first rule is that you should start with what you are looking for. What are we looking for in this question? We are looking for milliliters. So we're going to go ahead and write that, milliliters. The second step says transfer across the units. All right, so we're going to go ahead and transfer milliliters over here. So milliliters. Now you need to look in your question. What in my question as milliliters behind it? And we have right here 5. So 5 as milliliters behind it. So we're going to go ahead and write 5 here. And 5 milliliters equals to 250 milligrams. So 250 milligrams go below that. We are not done. You also, again, the second set questions, the third step says insert what you know, and that was what we did. We inserted 5 milliliters, we know that. We inserted 250 milligrams, we know that. And the fourth step says repeat step 2 and 3, which is to transfer across unit and insert what we know. So we're going to keep doing that. So we're going to transfer across unit. So milligram comes up here. So we're transferring from here to here. And in our question, we need to look again. What other number as milligrams behind it aside from 250? Because we already brought 250 down here, right? But we have 200. We have 200 up here. So 200 goes in there. And we can just put 1. So now the next step, the fifth step says multiply across and divide across. So that's what we do is 50. So milligram cancels out milligram, by the way. So we have 5 multiplied by 200 divided by 250. And like I said, I hope you have your calculator with you. So we're going to do that. 5 multiplied by 200 divided by 250. You should have 4 milliliters. All right, and that's what we're looking for. How many milliliters would this nurse administer? The nurse would administer 4 milliliters. The final step says record your round your answer. And the question did tell you to round your answer to the nearest whole number. Our answer is already in the nearest whole number, so we are leaving it at that. So that's our final answer for that. Okay. So our next question is a weight-based conversion, still using dimensional analysis and the rule. The question says 3 grams 5 microgram per kilogram by injection is prescribed for a client who weighs 132 pounds. The vial label reads 3 grams 300 microgram per milliliter. How many milliliters would the nurse administer? Record your answer using a whole number. So what are we looking for? Because that's what we always start with, right? The question is asking you how many milliliters. So we look starting with milliliters. That's what we're looking for. The next step in our rule says transfer the units across. So once again, we're going to go ahead and transfer the units across to this side, milliliters. And the next rule says insert what you know or convert. We need to look at our question. Do we have anything, do we know anything that has milliliters behind it? Yes, we do. We have 300 microgram per milliliters. So anytime you just see a number or metric value by itself like that with just milliliters, always assume it means 1 milliliter. So that's actually just 1. So we're going to go ahead and write it 1 milliliters over 300 microgram. Once again, you're going to transfer because the fourth rule says repeat step 2 and 3. So transfer unit across, insert what you know, or convert. So transferring MCG up here, MCG, you have to ask, do I know any number that has MCG in front of it? Yes, we do. We have 5 up there, 5 MCG per kilogram. So 5 MCG per 1 kilogram. All right, so the next thing is for us to transfer kilogram up there. We're still repeating step 2 and 3. So kilogram goes up here. But there's a problem. I don't know if you noticed, we don't have any other number that has kilogram in front of it. But we have 132 pounds. So how do we make that work? If you remember, if you go back in this tutorial, if you remember, we talked about the metric conversion table, and I don't know if you caught it, but one kilogram is actually equals to 2.2 pounds. So yeah, that's our magic conversion that we're gonna go ahead and insert into this box right there. So we're gonna go ahead and insert it. 1 kilogram equals to 2.2 pounds. Beautiful. So that allows us to transfer pounds up here. I'm just going to go ahead and box this off so we don't get confused. That allows us to transfer pounds up there. And now we have something that has pounds in our question that we know and we can insert, and that's 132. And we're just going to put 1 to replace down there as a placement. So we can go ahead and cross out. You should be able to cross out everything except milliliters because that's what we're looking for. So microgram crosses out microgram, kilogram crosses out kilogram, pounds crosses out pounds. And step 5 says multiply across and divide across. That's what we're going to do. So we have 1 milliliters multiplied by 5 multiplied by 1 multiplied by 132 divided by 300, which is multiplied by 1 multiplied by 2.2. And I wonder what that is going to give to us. Let's do that together. So grab your calculator. So 1 times 5 times 1 times 132, you should have 660. So 660 milliliters divided by 300 times 1 times 2.2 should give you 662. You should also have 660. So 660 divided by 660, you should have a final answer as 1 milliliter. And this is already in a whole number because that's the final step, rounding your answer. It's already in a whole number, and we're going to go ahead and stop right there. So this is another way of, using dimension analysis to solve another type of question that is a bit more complicated than the first question that we did. All right. So the final type of question we're going to look at is drops per minute. And the question says that a healthcare provider orders 500 milliliters of normal saline to be infused over 120 minutes using a tubing that has a drop factor of 30 GTTS per minute. You will set the flow rate at how many drops per minute to accomplish this order. Round your answer to the nearest whole number. All right, so again, the first step is to ask ourselves, what are we looking for? And we are obviously looking for drops per minute. All right, so we are going to go ahead and write that here, drops per minute. And again, the next step is to transfer over. So GTTS comes here, also known as drops. And we need to ask ourselves, what do we know? What do we know in our question that asks GTTS or drops behind it? And we have one right there, and that is 30 GTTS. So 30 comes here, and ml comes with it. So 1 ml. So again, we are going to go ahead and repeat that step. So ml comes here, we transfer that up here, and we ask ourselves, what in our question again as milliliters behind it? We have 50. Okay, so we could bring 50 down here. So 50 ml of normal saline to be infused over 120 minutes. So 120 minutes comes down here. And this is kind of where we stop, because now we can cancel out mLs and mLs, and our final answer is in GTT over minute. So what we're going to do is go ahead and multiply across and divide. So we have 30 GTTS multiplied by 500 and divided by 1 times 120 minutes. So 30 multiplied by 500 should give us, let's get out our calculators, will be 150, actually 15,000 drops divided by 1 times 120 should give us 120 minutes. And if we go ahead and multiply that, divided by, so 15,000 divided by 120 should give us 125 GTTS over minutes. And that's our answer. And the question says to round your answer to the nearest whole number. Unfortunately, our answer is already in the nearest whole number. And that's our answer. All right. So that's how you use dimensional analysis to solve drops per minute.
And that is it on this tutorial on dimensional analysis. I hope you have learned a thing or two. I hope by now you know what dimensional analysis is. You can do your conversions, and you can use dimensional analysis to solve at least 3 problems that we've looked at today. And practice, practice, practice. Remember your 6 rules, follow it, and you are going to be just fine. Hey, I can't just leave you like that, right? So I'm leaving you with this math problem on the screen. So solve it, and the answer is at the right bottom corner of the screen. Very tiny. You're gonna have to look very closely. All right, thank you so much for your time today. I really appreciate it. I will see you again next time. Bye-bye.